Hello. Hello, everybody. Yep. Welcome to the event. So today we are going to have our third or fourth event of ETH Penang. So today we have two speakers. One of them is Trif, and another person. Trif will be talking about protecting your blockchain asset. The best practices of the securities for protecting your assets online in the blockchain world. And myself, Julius, I'll be talking about layer 2 rollup, the introduction of it, and then what's the in and out of it. So yeah, without further ado, let's welcome Trif.
Hello. Okay. Hi everyone. My name is Chief, and in this talk we're going to talk about protecting your blockchain assets. So this is quite beginner friendly. So if you don't have any experience in blockchain, that's fine. We will be covering some overlap between general security practices, but we'll touch more also on blockchain specific security practices. Yep. And all of the security practices that I'll show you actually has case studies, or people have gone through or have been exploited from these, and so we can learn from what has happened before. Okay, I'll just give a brief introduction about why do we need to talk about blockchain security. We'll start with creating your wallet using MetaMask. I'll give you some tips on how to avoid certain pitfalls or failures in terms of MetaMask. We'll talk about connect, signing, and approvals. This is one of the basic interactions, blockchain interactions that you can do, and it's very important that you understand what's going on. We'll talk about hot and cold wallets. Why do we have hot and cold wallets? What are the differences, etc. Website domains. This is just a short one for your information, and we'll touch on general security practices that everyone should adhere to when working online on your computer. Okay, so first an introduction. Why do we talk about blockchain security? Because blockchain is hard. It's hard because, one, it's closely related to cryptography, right? The technology is so close to the user interface where the users interact with blockchains and a string of characters that it's kind of hard to understand what are the security practices that we must do in order to protect our assets. And this is also because blockchain is designed to be an isolated system. We do not rely externally on things that we already know about. For example, emails. Email addresses. Right? In Ethereum, we use hex strings, a string of characters as an address. This is not very user-friendly, but it's because it's deeply rooted in cryptography, and also that we want it to be isolated. We don't want to rely on external systems, because if anything happens, we can continue with the blockchain, continue to survive. And also, it's very fast-moving and always changing. And so we need to be, when new things come up, then we need to understand what are the common pitfalls that people do when interacting with such new, let's say, workflow when it comes to managing your blockchain assets. Okay, I'll give some best practices how to secure your assets, specifically your blockchain assets, and also simplify and explain some basic blockchain interactions that you go through every day, but you might not understand what's going on, and it's not your fault, right? Because of the nature of blockchain, but it's our duty to educate ourselves on what's going on. Okay, first we'll touch on creating your wallet. So, as you know, in Ethereum we have, it's okay, I hope everyone can see. I think the projector is a bit upwards. So there's two kinds of wallets, non-custodial and custodial. What are the differences? Custodial means that a third party controls your private key and your assets. They actually hold your assets. And how do they manage their assets? How do they combine everyone's assets together, and where are they putting them? You have no idea. This information is not given to you. You may be able to track on the blockchain what are the flows, inflows, outflows, but it's very obscure. And on top of that, they require KYC, know your customer. This is a regulatory thing that they need to satisfy. But with that, they can help with account recovery, right? So not necessarily if you lose your funds, they can recover your funds, but in terms of access recovery, they can help you do that because they have your personal information, right? And so custodial wallets, I would say they are like Binance, Kraken, and KuCoin, your main exchanges, decentralized. Your main centralized exchanges, right? If you heard about people losing money in FTX, which was the exchange that blew up many months ago, then that is what it means by custodial. They were holding the assets and they went down and then everyone lost money. Okay? So the next wallet is non-custodial. What does it mean? So there's both software and hardware wallets for non-custodial. Why non-custodial? Because you control the private key. You control the private key to the address that's assigned that you have, and you can do whatever you want, and there's no third party that is able to control what you can do with the assets in your address, controlled by your private key. And of course, no KYC. We identify each other using a string of characters as your address, and because of this, you are solely responsible to protect your wallet and your recovery phrase, right? So we have this 12 words that determine how do you generate your private key, and you need to take care of these 12 words recovery phrase. And common examples of non-custodial wallets are MetaMask, Rainbow, and also Ledger. So MetaMask and Rainbow is a software wallet, and Ledger is a hardware wallet. We'll talk about them more later. Okay, important note. So this is a common misconception. What is it? The assets that you own is not stored in your wallet. Your wallet is not something that is a container that you can put in assets, actually, because blockchain is a digital ledger. Digital ledger, which means it's all accounting. Your assets are on the blockchain, not in your wallet. So what does the wallet do? The wallet actually lets you view your assets and sign transactions, right? So your wallet actually holds your private key, and they can help you sign a transaction that you want to do in order to transfer your assets. Right? This is a very common misconception. People think that if they lost money due to MetaMask, they can email MetaMask support to help them. No, MetaMask is only like a window to the blockchain, and whatever happens in the blockchain world, that's an entirely different thing, because MetaMask does not hold your assets. It's just a window or interface to the blockchain, right? Now, very common wallet recovery phrases, recovery phrase security practices. When you write down your 12 words that comprise of your private key, that comprises your private key, do not store it digitally, not in a notepad, not in cloud or whatever. You need to write it on paper or something physical, and you store it in a secure location, right? It's because if your computer is compromised, then they are able to find this text file, or your cloud account gets compromised, then your private key will be taken and your assets will be taken as well. Have multiple copies in secure locations. There have been many cases where, they write down the secure phrase in a paper and it's just lying in their house, and someone throws it away. And once they lose their assets, then they are unable to find that piece of paper that holds all of their assets. So this is a common pitfall also. Please have multiple copies in secure locations. Do not share an input to untrusted applications. Basically, you do not input your 12 recovery phrase unless you want to recover your wallet. If anything else, like for example, a protocol or an application asks you to put in your seed phrase, do not do that, right? So these are the common ones. So for recommendations, if you are doing DeFi and NFTs, I would recommend MetaMask. So you can go to the link direct to the website directly, metamask.io. Do not be fooled by other websites that pretend to be MetaMask. And for cold storage, I will recommend Ledger. And we'll touch upon on this in hot and cold wallets. Okay, using MetaMask. So I think one tip that I really like to tell everyone about using MetaMask is using the nickname feature. Actually, MetaMask has a nickname feature. Who here uses the nickname feature? Raise your hand. Okay, that's very good. So this will be very valuable to everyone, right? So what's going on? When transferring assets to a new address, you need to check all the letters in the address. Don't check the first 4 and the last 4. Check all the letters for the first time, right? The address that you are sending your assets to. Then you can give your address an identifiable nickname, right? And so we will go through how to do this. It looks like this, right? You have this random, this string of characters. There's someone's address. but it's very hard to check each letter. So we use this nickname feature in order to make it easier for ourselves. And I'll go through it just quickly here in the slides. Okay. So first, when you are sending your transaction, right, you paste in the address that you want to transfer, right? You paste your address and check. Check each letter that you're putting in, right, that you have pasted in. After that, you set your amount, how much you want to send, and then you click next. So it'll go to the next part. In this part, this is where you determine your gas price, right? For every transaction, you need to pay a gas fee. So this is your payment to the people who secure the Ethereum network. And so in this page, you actually click here. Click on the top right at the address there. You click there, and then it says here, it shows you the address, and then you see the add nickname button. You click on the nickname button. Right? So once you click there, what happens is you get to this page where you're able to put a nickname and also a memo. Right? Put whatever your counterparty's name. You check again the address. This is the last time. Then once you check this, basically you can set the nickname and save. Now, what happens when you do this actually is very convenient, because when you copy paste, when you transfer your assets again, right? You click on transfer. You are in this page. You can see that actually the name of your the addresses that you have assigned a nickname is there, right? And so, or you can even just paste the address. And if it's someone that you have already set a nickname to, you can see that there's they put the nickname there on the top, right? The nickname is shown here. So you are absolutely certain that it's the person that you are sending your assets to, right? This is very key. Okay. If you are transferring to a wallet that you control, so in MetaMask, you can have multiple wallets, right? And so when you're transferring to a wallet that you control, you click on this button here, which is the transfer between my accounts. And this will display to you all of the accounts that you own in your MetaMask. And you can just click directly. And again, you do not make any fatal mistakes in terms of sending your assets to the wrong address. And it's not just about sending assets to the wrong address. It's because the main reason why is because actually your PC's copy and paste mechanism can be hijacked. This has happened before, where if your PC is compromised, you copy something, and then there's a virus in the background that identifies, oh, this is an Ethereum address, so I will paste in my own address. And you go and paste it somewhere, and you don't realize that it's actually a different address, and you have sent your assets to the wrong address. Hackers can also try to create a wallet and address similar to yours. This is very interesting. This is very interesting. Why? Because in Ethereum, you have your 12 words that create your private key. Your private key creates your address. So what a hacker can do is actually they can generate millions of addresses every second in order to find an address that looks similar to yours. Maybe the first 3 letters and the last 4 letters is the same as yours, but in the middle, it's different. But when you are at this page and when you are looking, like, you can't tell the difference, right? Is that really your address? And so these are the things that have happened before, And one of the old tactics was that these hackers, they would generate an address that looks similar to yours, and they send you some money into your account. And when you check Etherscan, which is the main website that you check all blockchain transactions, you'll see something that looks like yours. And when you wanted to send an asset to that wallet, it's actually the hacker's wallet that looks similar to yours. So this is very important. So that's why the nickname feature, I think, is very useful for everyone. Okay, connect signing and approvals. So we'll talk about this. Basically, the first thing that you usually do when you go into a website, a decentralized application, is connecting your wallet. So what does connecting mean? Connecting means allows the website to know your Ethereum address. That's all. Allows the website to know your Ethereum address. Why? This is because they would like to display your addresses, balances, and positions. Whatever positions you have or whatever assets you have related to that application, they are able to show that, right? So this is connecting. Now, it is usually safe if you never sign any transactions. If there's no transactions, you just connect, that's fine, right? It will look something like this on the right, right? Connect to the website. Now, in terms of connecting the wallet, how do you disconnect? When you are connected to a website, in your MetaMask, when you open it, you can see there's this connected word here on the top left, right? You click there, and it shows you what accounts you have connected. You click disconnect this account, and this will disconnect the account. It'll just let the website no longer know what is your Ethereum address, Okay? Okay, we'll talk about signed message. So this is interesting. Digitally sign a message using your private key, right? So when you send a transaction, you digitally sign that transaction with your private key. But this is cryptography basics. You can also sign anything, any message at all using a private key. And this proves that you actually own that address because you own the private key and you're able to sign something with that private key, right? A signature request, a signed message looks like this. It's a signed signature request in the application that you are accessing. And it doesn't send an Ethereum transaction, which means that you do not pay gas fees. And it proves to the website that you own the private key, right? Usually safe if the message is talking about accepting a terms of service, right? So accepting a terms of service, you can see here, if it's talking about accepting a terms of service, it's okay, right? Because there's nothing actionable that can be done using that signed message on the Ethereum blockchain. However, be careful if it talks about permit. Permit, I will explain later on. What is permit, right? Please be careful because this can involve your assets, okay? Even though you don't really sign a transaction, and I'll explain why later. And absolutely do not sign if the message is unreadable. If it's just a random string of words, letters and numbers, do not sign it because you have no idea what it does, and it might be something malicious. Okay, approvals. Approvals, very common action that we do. What is it? We send a transaction to allow another address, user or smart contract to access our funds, right? So instead of sending our funds, we actually set an allowance for an address to be able to access our funds at any time, right? So we can actually specify the amount that we would like that person, that user, or that smart contract to be able to access our assets. It looks something like this on the right, right? So here I'm just it's also called a spending cap. Someone is allowed to spend this amount for you. Yeah. So for approvals, please check the website URL. You need to check the website URL to ensure you are not signing an approval on a random website. And, okay, so there's two options here. The first one is max. Use max, which is here, only to approve the amount needed for the smart contract interaction. If you are doing something that involves like one phantom, then when you click max, it says there one phantom, right? This is one phantom. This is usually my recommendation on what you should do. You can also use default, but use default is approves an infinite amount, so you don't have to approve multiple times. So approval means you need to send a transaction and you need to pay gas fees. But if you don't want to do it many times, then you can just approve an infinite amount, right? So for you technical, for those technical guys, it's 2 to the power of 256 is the maximum amount, which is infinite here. But I will advise you only advanced users use this. Why? Because you can set infinite approval if, let's say, for that address you do not store too much of your assets. Maybe a small percentage of your assets is in that address, then you can use something like this. And if you're able to manage it well, then you minimize your risk when it comes to assets or addresses that have infinite approval for an asset. Okay, and because approvals, when you set the allowance once, infinite, then in the future, if an upgradable smart contract has some bugs, then hackers are able to take advantage of that and actually take your assets from you. This is already something that has happened before, right? So please be careful when you are using infinite approval amount. Okay, why do we need approvals? Basically, ERC20 token is a token smart contract. ERC token is a smart contract. Your DeFi app that you are using is also a smart contract, right? These are two separate smart contracts that you're interacting with on the blockchain. But the problem is that we cannot interact with two different smart contracts in a single transaction, right? So we can interact with one smart contract, and then that smart contract can interact with other smart contracts. But from our perspective, we can only interact with one. That is why when you do when you do a swap or a deposit action, you need to approve first, and then you do your action. This is something that's especially specifically for ERC20 tokens, right? Tokens on the blockchain. Okay, permit is similar to approval, but instead we sign a message saying we allow the transfer of X tokens to the smart contract. So yeah, it sounds like approval, but actually the difference is that we do not send a transaction. You do not send a transaction, you do not have to pay the gas fees for the approval transaction. This is actually a signed message, again, signature request, and this signed message is included in our main smart contract interaction. So whatever you're doing, your swap or whatever, they'll bundle this together with your main contract, with your main contract interaction. So you only have to pay gas fees once. Right? This is permit. Right? And again, it's a signature request. Basically, you are signing a message that can be verified on the blockchain that says you are allowing this user or smart contract to take your funds. Yep, so we only need to send one transaction instead of two, and we save in gas fees. Now, again, for permits, you also have to double check the website URL. Make sure you are not signing a permit message on a malicious website. Because bad actors can use this to steal your funds. Even though you think, oh, I didn't even send a transaction, but actually, because this has been signed, it can be verified on the blockchain and your assets can be taken from you. Yeah, even though you did not even send a transaction, this permit signed message can be used against you. Okay, why do we have permits? Basically, this is a feature that was improved upon approvals. Right? First we had approvals, then we said, we had to send 2 transactions, so they created this permit in order to save on gas fees. That's why permit is here on top of approvals. Okay, now to remove approvals and permits, basically you use this website here, revoke.cash. I'll just go through this quickly. Basically, you connect your wallet to the website, you go directly to the URL. Connect your wallet, you paste your address and select the network. There's multiple networks it supports. And you click revoke for the asset and smart contract to be revoked from. So you can see here, I previously have approved unlimited DAI to this Uniswap contract there at this time. And so I need to revoke. When you revoke, you are setting the allowance to 0, which means nobody can, that smart contract is no longer allowed to spend your assets. Okay? And then finally, you click approve to sign the transaction. It looks like this, yeah. And you just approve and sign and send a transaction to the blockchain. Okay, hot and cold wallets, we'll go through this a bit quickly. Hot wallets are wallets where you frequently interact with smart contract applications. Whatever your approvals, your swaps, your deposits, this is the wallet that you use to interact with all of the smart contracts. A cold wallet, on the other hand, is where you only do transfers of assets. You do not do anything else, just transferring assets to and from this wallet. This is what we call a cold wallet, right? And why do we do this? It's because we guarantee that the wallet, the assets stored there are not at risk of smart contract bugs. Yeah, this is important because I told you that smart contracts can be upgraded or there might be bugs that are discovered later on. Then this is important. Now, hardware wallets are the best and remain secured even if your PC is compromised. You have software wallets and hardware wallets. If you have a hardware wallet, the private key generation is on the hardware wallet. It's an external device. And so if your PC is compromised, they are unable to get access to your funds because the private key is outside. It's in a small device that is separate from your PC. So hardware wallet that is a cold wallet is the best thing you can do for your crypto security. It's the most solid form of storage of your blockchain assets. Please do not use a ledger or a hardware wallet as a hot wallet. Yeah. And another tip is create new addresses when interacting with new apps. Yeah, this limits your assets under smart contract risk. Yeah. Okay, quickly on website domains. What is a domain? A domain is uniswap.com or sushi.com. Whatever is .com or .xyz or .fi, I believe. Yeah, that is the domain for that project or protocol, right? A subdomain adds another hierarchy, another word beside the domain. So app.uniswap.com. docs.sushi.com, right? So when accessing a new website, you need to check the URL. Please check the URL. If the domain is correct, it is usually safe. If it's uniswap.com, sushi.com, it's safe. If the subdomain is the same domain, it's usually safe, which means that if it's an app or whatever .uniswap.com or whatever .sushi.com, it's safe, right? If the domain is entirely different, then it is not safe, right? I think this is for, even though maybe for us people who are used to computers, we find this very obvious. Actually, a lot of people get hooked by fake domains that are promoting things like free money, right? So here I have an example here. You can see that your URL is different, claimbsc.org, right? So this should give you a red flag that this is not actually correct, right? So please, just a heads up to everyone on this. Okay, you can also bookmark the apps that you frequently use, yeah, just to make sure that you have the correct URL. Okay, I think the second last slide already. Security best practices: do not click on random links. Do not open files or execute programs from untrusted sources. There have been cases where um, whatever file you have, it might be compromised, right? For example, so you need to use a clean secondary PC or a virtual machine to open some links or some files that you're using, especially if you are job hunting or recruiting. PDFs can have malicious packages that actually compromise your PC. Or if you're working in Web3 gaming, right? Game demos can also have malicious code inside, or malicious viruses inside. And so this is something that has been occurred already, has happened already. For example, for job hunting PDFs, Harmony Bridge got hacked for I think $200 million way back ago. And because the recruiters were getting PDFs, and it turns out the hackers was a North Korean hacker. Yep, so something that has happened before. Enable 2FA when available. Keep your PC and browser updated. Be wary of emails about blockchain, right? Because there's a lot of emails about blockchain, but in fact, MetaMask never asks for your email. MetaMask doesn't ask for your email, but then you get emails from MetaMask. This is something, you should realize that this is something wrong, right? And also MetaMask, again, as I explained, does not hold your assets. They are just, they provide a software window into the blockchain world. If it's too good to be true, it probably is. So please exercise judgment in terms of this when you are looking at news online. And nothing is 100% secure, but we can always improve our security, right? So this is something that we should keep in mind, okay? Okay, I think that's all from my side. I just want to shout out for a hangout session. What is a hangout session? Basically, once every 2 weeks on Thursday nights, we have some kind of chill, casual talking on Discord. And we talk about whatever's happening recently. Or if anyone has any questions, beginning questions, they can actually highlight it in this session, right? So once every 2 weeks on Thursday nights, 9 p.m. to 10 p.m., we announce it on Monday. So on the Monday before, we will announce it on we will do it in that week's Thursday. And this is the perfect time to ask beginner questions. If you're just learning about blockchain and whatever, you want to ask career questions, blockchain technicals, programming, you can ask in this. We can accommodate for you in this session. And we usually have a backup topic. Usually it's something that has happened during the time. For example, I think 2 weeks ago, there was the atomic wallet hack. We were talking about wallet security and things like that. What happened to the atomic wallet hack? And so on, right? It's a casual setting, free. If you want to just join in to listen in, that's fine, right? If you don't want to talk, that's fine. This is the link to the Ethereum Penang Telegram group, right? If you would like this, I think Julius also later will share this link also. So you can join in to get any updates from that. Okay, that's all from me. Any questions? Maybe just one question, okay? Okay, so certificate meaning probably the HTTPS certificate on your browser. So yeah, you can do that. Although I'm not an IT security expert, I'm not sure whether, for example, I understand that any website can have HTTPS. Yeah. Okay. I don't think we're familiar with this. Also, I'm not aware of any. I think from what I've heard in terms of the URL, what I've heard before that's happened is basically DNS hijacking. That's one part that I remember. But from the certificate side, I don't think I'm familiar with that. Probably we can get more info on that as well to add in. I think, is there any other question or not? We can move to the next talk already. The Hangout session is online on Discord, the ETH Discord. Sorry to, but you can follow the announcement on the Telegram group. Okay, so I think I didn't touch on multi-sig wallets because it might be a bit too technical or too a bit advanced in terms of crypto usage. But overall, I would say that in terms of security practices, you should have one PC where you are doing at least just blockchain stuff, but you do not install any messaging apps like Discord or Telegram or whatever. Yeah, just one PC that is doing all the crypto activity. You do not use Discord or Telegram on there. Why? Because people can actually hack Discord accounts and impersonate your friend or your colleague that's working there, and they can send you, even though it looks legit, it's actually not. Right? I think this just happened also. Right? Someone got impersonated, or the Discord was hacked, and they impersonated the colleague. Yeah. So probably one PC, clean PC with for your blockchain work. Just MetaMask is fine, and you can have one hardware wallet for your cold storage, something that you want to hold for a very long time. You use the hardware wallet. Yeah. Sorry, does that answer your question? Okay. Okay, I think we need to move on to the next talk already. So I think that's all from me. Thanks.
Wow. Okay. Hey, hi everybody. So today I'm gonna talk about layer 2 rollup. So just want to get a hands. Anybody know about rollup here? Anybody? All right. All right. Okay. Okay. All right. So the topics that the agenda that we're going to cover today is the first the fundamental limits on blockchain, and we're going to talk about why do we need to learn rollup, and what is a rollup, and finally we talked about some of the layer 1 improvement for a better rollup, right? Okay. Let's get on to it. So the fundamental limits in blockchain. So blockchain is expensive and slow, right? So why is it expensive and slow? So when you are a developer that is developing a layer 1 blockchain, there's a lot of consideration and trade-off that you need to make, right? So there are actually 3 very desired properties for a blockchain. The first one is scalability. Second one is security, and the third one is decentralization. So basically, these 3 properties are a very much desired properties for a blockchain. But when you, as a developer who develop the layer 1 blockchain, you somehow or rather need to make certain trade-offs to enable maybe just 2 of these properties, and the other properties is automatically been not be able to be catered for. Like for example, right? So if you wanted to improve the decentralizations of your chain, and because of this, somehow you will sacrifice the scalability of it. Because when you want the decentralization, you mean you are going to add, you wanted to encourage more nodes to join your network. When more nodes join the networks and everybody has to do the calculation, it will be slow, right? It affects your scalability. So this is the blockchain trilemma that is coined by, I think, Vitalik. Okay. And yeah, so basically scalability refers to the total number of computation that the network can process per second, which is your TPS, right? Your transaction per second. And your security is the amount of resources that is required to actually take over the whole network, right? And decentralization means the number of full nodes that is participating in the network. So it is not impossible to achieve all these three properties. So Vitalik has a saying that getting these three is not impossible, but it is very, very hard, right? So even Ethereum today has not been able to achieve this. It is in their ETH2 roadmap to achieve this, but I'm going to cover the roadmap in subsequent slides. And Ethereum make a very sensible choice to, they choose security and decentralization. So this is very, at least in my opinion, is very good choice. And they're choosing these two because a blockchain by itself, if it is not secured, nobody is going to use it, right? If it is not decentralized, it is no different from Web2 applications or Web2 world. So these two is quite sensible, and to me is pretty good, the choice. So what was being sacrificed, which is the scalability, right? You trade off scalability. Because you trade off scalability, it will lead to high fees and slow execution time. All right, so let's talk about that. So if we choose these two, security and decentralization, so which means that you will encourage more nodes to join your network. The more nodes that join your network, the more stakes that you have in the network, the more difficult for hackers to overtake the whole network, right? So let's say everybody, when you want to be a validator, you have to stake 32 ETH today, right? So let's say you have 100 nodes, 320 ETH, right? So for a hacker to take over the whole network, you got to have a 51% attack. So how much is half of 320 ETH? That's a lot. That's a lot of money, right? The larger the validators nodes that you have, the more secure your network is. So that's why we said decentralization encourages security. So when you have more nodes, you to encourage more nodes, you will have to make some choice where the validators cannot. Most of the validators cannot have a very high-end hardware when they do the validation, right? When you do mining, if you understand that terms more, right? So Ethereum basically, if you want to be a validators, you just requires a moderate hardware, which is just a consumer grade hardware, just like a PC, and you can immediately install the node software inside and do the validations, right? And with this less powerful hardware, it comes with less processing power, right? And because of less processing power, it leads to lower TPS, transaction per second. And because we are processing less transaction and the network become congested, because Ethereum resources are very scarce, the block space is very scarce, but a lot of demand for the block space. So it become congested, and because it is congested, the fee is high now, right? Because people wanted to get their transaction into the next block as quick as possible, and people are willing to pay a very high price for that, right? So now you can see we choose security and decentralization, and eventually it leads to lower TPS and higher gas costs, right? Okay, so this is an example of the higher gas cost. So whenever there's a big event that is happening in Ethereum, you will usually see the gas fees become a spike up. Like for example, when you have this Pepe project that is live, the gas fees shoot up, and same for this NFT times NFT. Okay, in terms of the TPS, if you can see the Ethereum is at about 12 to 15 TPS. That means 12 to 15 transactions per second, right? If you compare that with the other chain up there, it is pretty low, right? So why are the other chains are able to achieve the high number of TPS? Because they sacrifices certain properties. For example, security, or for example, decentralization. So they made a trade-off, they made a choice for their chain to sacrifice certain properties. That's why they can get a higher TPS. And these numbers, just take it with a grain of salt. So this is the number that I get it from the internet. And it might not reflect the real things, but it's pretty close, right? If you compare with the Web2 world, with the Visa and PayPal network, they are at about, Visa is about peak 45 TPS, 45K TPS. If you compare this with Ethereum, Ethereum has no way to overtake Visa's speed, right? And for PayPal, we are also not close at all. So for Ethereum to be ambitious enough to be the blockchain that runs the whole world, so this is definitely not enough, 12 to 15. Okay, so why rollups? Why are we talking about rollups? Right? So we have our regular Ethereum there. Ethereum is good, we know about it, and it has been there for so long. Why do we now talk about something else? Rollup. Okay, we talk about rollup because of this, right? This is a blog post proposed by Vitalik somewhere around October 2020. So he made a roadmap change to Ethereum, right? So the old Ethereum, we have a 1.0 roadmap, a 2.0 roadmap. And the 2.0 roadmap is actually able to provide the scalability that everybody is looking for, right? The aim of Ethereum is to power or be the underlying network for the Internet of Value in the future. So to achieve that, Ethereum needs to run at about 100K TPS to make sure that everybody in this world can leverage it and do whatever their daily life, transfer of value in their daily life. So, but to achieve that, it is very difficult because Ethereum fundamentally has a scalability issues. So now Vitalik come in with a direction change. He's proposing something called roll-up centric roadmap. So basically, Vitalik is saying that Ethereum ecosystem is likely to be all in on roll-up in the near and mid-term future. So that means Ethereum Foundation is not going with their existing 2.0 roadmap anymore. They make a detour to do something else that enable the roll-up ecosystem to be there first. And as you can see, the original ETH2 roadmap promises the high security execution shard and a scalable data availability layer. But that vision is really years away. So it is many, many years down the road. It is not like a walk in the park. To come up with that much of scalability, you need a lot of R&D, you need a lot of development testing cycles, a lot of DevNet, testnet, and go through a lot of things. So it's not really easy, and it is years away. So before we reach that vision, what can we do now? If we don't do something now, people are going to move away from Ethereum to some other chain, which I have shown previously. The other chain has much, much higher TPS. So why would people stick with Ethereum if we don't do something now? There's no reason, right? So now, if we talk about ETH2 roadmap, there's actually three phases. Phase 0 and phase 1 is done. So phase 0 is the beacon chain. Phase 1 is the merge. The merge is the when we actually change from a proof of work to proof of stake, right? And the phase 2 is about sharding. So this sharding is the one that is going to bring the scalability that Ethereum needed. But it's years away. So we are making a detour. We are going in with a roll-up centric roadmap to focus on doing just the things, certain things well, which is consensus and data availability. So we don't, Ethereum is not aiming to do execution well. It is just aiming to do consensus and data availability well now. Because these two are exactly what Rollup needed in the near term, right? And it also potentially just go with, probably can just go with phase 1.5 and done. That means once this roadmap is done, right? The rollup centric roadmap is done, right? So Ethereum can basically all in on rollup, and the rollup can potentially provide the scalability that the whole Ethereum needed. And there is no more such a requirement to continue on back to the original roadmap to do the sharding. So that is why there is a potential that we just stop there. And the future will be just roll up. Okay? Yeah. So if you are developers, you most likely will need to develop on a roll up rather than on the main chain Ethereum. Yep. Okay, so what is a roll up? Okay, let's quickly go through what is a roll up. And roll up is the preferred layer 2 solutions to scale Ethereum. All right, so it's from the Ethereum Foundation that this is the preferred way for now. And it bundles a lot of transactions in layer 2. Rollup is a layer 2 solution. So you bundle a lot of layer 2 transaction and submit a single transaction into layer 1. That is called a rollup action. And it can potentially reduces the gas cost by about 100x compared to the layer 1. And what is a rollup? Rollup is basically just a separate blockchain plus another bridge, right? So it's not part of the Ethereum. It is a separate chain, but it's relying on Ethereum for its security. So the rollup will execute transaction outside of the layer 1, but they will still put the transaction back to Ethereum layer 1. And I mentioned this, it inherits the security of Ethereum. And for us to implement rollup, we don't actually require any change to the existing Ethereum protocol. Okay, so the one in the middle that you see under the blue box, that's rollup. Okay, so under the new trends of developing blockchain system, we are starting to go into a modular blockchain world, right? So Ethereum used to be a very monolithic kind of model, right? If you look at the first one, the monolith model, so Ethereum nodes will build in all those 4 particular modules, which is the data availability, consensus, settlement, and execution. It's all in one bundle in the node software, right? But for rollup, we separate out the execution from the chain, main chain. Why we separate the execution? Because execution is the one that is the slowest. So every single full node that secures Ethereum, the node has to execute every single transaction and generate and update their own states. And every single execution takes time. So that is why it is slow. So we now move the slowest part out of the main chain, but we do the calculation at another layer. And once the calculation is done, we roll up whatever the end results back to Ethereum. That's a rollup. Okay. So which are the existing rollups that we have today, right? So this is a list from L2Bit. L2Bit is a very very informative website, which if you want to know about rollup, you should go. And they listed about 23 here, the active project. There is still a lot more in the upcoming project. So there are a couple of very famous ones like Arbitrum, Optimism, and ZK Sync, maybe you know, Loop Ring, Immutable, and maybe you know Polygon and Starknet. So these are the popular ones, right? They each have different properties. And this website itself did a very good job in analyzing all this roll-up and provide you all the information in there. So if you want to know, you can go there, the website. Highly recommended. Okay, so roll-up. There are two main kind of roll-up today, right? Two main way of doing a roll-up. In fact, it doesn't have to be constrained to just two. If you come up with a way for you to prove to Ethereum layer 1 that you have did some calculation and did it right, but not using optimistic way and not using zero knowledge way, then you will have a third type of roll up. But for now, a lot of great minds in the world, they have sit down, they have discussed, think about it. So these are the two that we have right now. So what is optimistic rollup? Optimistic rollup is a rollup that relies on fraud proof to prove to the Ethereum layer 1 that certain calculation is done. So in fact, optimistic rollup does not actually send any proof to L1. It is optimistically assume whatever transaction that is done by the L2 nodes are actually correct. So by optimistically assume, that means there will also be a risk that it is not correct. So that is why for optimistic rollup, there is a period of 7 days, challenge period, where within that period, anybody or any nodes can challenge the proofs that was submitted to L1, right? So if the rollup wanted to cheat, and the rollup actually sent invalid states back to Ethereum, actually anybody or any other nodes can actually do the calculation and find out the rollup is cheating. So they can, when they found out the rollup is cheating, they can actually challenge it, and if the challenge is successful, they can actually gain some money. Okay, so that is the optimistic rollup. So how about zero knowledge rollup? Zero knowledge rollup is using validity proof. So how does zero knowledge rollup prove to Ethereum that the calculation is done correctly in layer 2? So the rollup is generating a validity proof using zero knowledge. And that proof itself can be sent over to Ethereum layer 1 and been verified by a smart contract in layer 1. And because of this zero knowledge proof, the proof size itself is very small, and the verification time is very short, so it is very suitable to be used in this particular scenario, right? So I will get into a little bit more details later. Okay, I'll just quickly go through this. You might not be interested in unless you're a developer. So okay, just a note to everybody. So whatever that I drawn here is the general concept about optimistic rollup. So if you go to any of the optimistic rollup, let's say Arbitrum or Optimism, you might see a different diagram. But this is just for your understanding the general concept of it, right? So every single rollup has their subtle differences, right? They make different choices on the design, but this is just a general concept. So for a rollup to work, right? So they have something called, okay, before that, the box at the top is the rollup. The box at the bottom is the Ethereum, okay? So if you can see, in the rollup side, we have something called sequencer, right? So the users now, instead of sending the transaction to Ethereum, now the users will send the transaction to rollup into a sequencer. The role of a sequencer is to accept the transaction from the users, execute the transactions, update its own state, and then generate the state roots, right? It continue to do that and accepting hundreds or thousands of transactions. And every now and then, the sequencer will actually batch up the transactions and send the transaction over to blockchain. So at one, if you can see the over there, at one point the sequencer can actually batch up a couple of thousand, let's say, 100 to thousands transaction into a single transaction that gets sent into layer one, right? So this from doing this, you can actually already see this is how Rollup is helping Ethereum to scale. Because if we do not have a Rollup, all the 1,000 transactions would have to get in directly into Ethereum. And that 1,000 transaction has to be processed by every single full node in Ethereum and causes some problems because of you have to do calculation 1,000 times. Now instead of 1,000 times, you're doing it just one time. So the rest of the calculation is done in the Rollup side, the sequencer side. Okay, so it's all and good. So Rollup put all the state roots and transaction time back to layer one. And it is sending all this information to layer one using something called core data. If you are a Solidity developers, you will know what is core data because in calling a smart contract function in Ethereum, EVM compatible chain, you need to make a call, function call, and that function call, if it contains parameters, you need to send data in through the core data parameters. So basically, Rollup is using exactly the same thing to send all the transaction data and the state roots to layer one. And it is sending those data to layer one for storage. It's just to store there, right? So once it is sent over to layer one to store there, then there will be a verifiers nodes, right? Come in and read the transaction data and generate their or update their own states and generate the state roots and compare the state roots with the one that is submitted by a sequencer. So if the comparisons fail, that means that the sequencer might be sending invalid state roots, right? So the verifiers can challenge. It will challenge the sequencer, then you get into a challenging game, and eventually who wins out will get some money, and the person who loses out will get slashed, whatever stake that they put into the network, right? So this is how the optimistic rollup works. So it's fast verification time. Data got sent into the core data. I've said this before. 7 days challenging period. And just one note here, optimism that you know today does not have the fraud-proof mechanism. It is still under development. So if you are using Optimism today, you are actually giving your full trust to Optimism team. Even though we say that this whole optimistic rollup relies on fraud-proof, they don't have a fraud-proof today. So you have to rely on trusting them. Okay. Arbitrum, on the other hand, has the fraud-proof mechanism built in already today. Okay, let's talk about ZK Rollup. ZK Rollup is slightly different in the sense that again, this diagram will look very different if you look into individual ZK Rollup architecture diagram. So this is just a general idea for you to understand how it works. So sequencer will accept transaction from users, and there will be an aggregator there to batch out all the transaction and send it over to a ZK prover. Right? The ZK prover is specialized in the zero knowledge algorithm, where you will basically The idea is that you have, let's say, the initial state A, right? So this ZK prover can come up with a proof that proves that for a given state A, with a list of transaction, I executed the transaction, this state A will become state B. And the prover can actually generate a proof to prove all this calculation. And the proof is very succinct, just a very small proof. And this proof can be sent over to layer 1 and be verified by a smart contract. So what does it mean by a successful verification? The smart contract verifies the proof. Once it's successful, that means the smart contract has 100% guarantees or cryptographic guarantees that given a state, the state A transitions to state B as a result of this execution. So the guarantees is that the smart contract does not have to execute all the transaction itself. You can have a cryptographic guarantee that it is done correctly in L2. So by doing that, you can have an instant finality. That means whatever that you actually breach it, the asset that you breach from L1 to L2, if you want to withdraw the asset, you can do that. As opposed to optimistic rollup, the asset is sitting there. You can't. It's not finalized until the challenge period is over. That means 7 days later only you can withdraw your money. But here, once the validity proof is verified, you can actually withdraw your money. Okay, so yeah, I think I missed one part where the zero knowledge rollup is not actually sending the entire transaction data over to L1. It is just sending the state diff. A state diff is a state differences. That means I don't need to send all the transaction like transaction 1, Alice sent $10 to Bob. Transaction 2, Bob sent $10 to Alice. All this, I don't have to send it over to L2. I just send the end result of the effect of the transactions over to layer 1. So why do we need to send the state diff over to layer 1? We need, layer 1 needs certain level of guarantees to allow people to exit from the chain if something bad happened to layer 2, right? For example, the ZK Sync, right? Let's say ZK Sync somehow or other they operated for two years, 3 years down the road, they suddenly get missing, the whole team missing, and nobody is operating it, and nobody has access to ZK Sync. So what happened? They are already asset being locked into layer 1 and bridge it over to layer 2. So what will happen? So with the data that you post into layer 1, the users would be able to do a social recovery. We can reconstruct the L2 states using whatever that is posted previously into layer 1. And then once you regenerated the whole roll-up states in L1, you can continue to extend the chain going forward. Yeah. Yeah. No, you send the entire transaction data. Yes. The reason why in the optimistic rollup you send the whole transaction is because someone has to generate the fraud proof, right? You cannot generate the fraud proof with just the state diff. You need to generate the fraud proof by executing the whole transaction. Yeah. So that is why in optimistic you send the whole transaction data, but in ZK you just send the state diff. But there are exceptions to this. If you look at Polygon ZK EVM, the new one that just came out, they actually also send the entire transaction data to L1. Yeah, there are differences between chain to chain. So this is just general concept. Okay, some other important characteristic or properties of a rollup that you need to know, right, as a developer. So this I already covered previously. And you also need to know that when you choose a rollup, you need to know whether the rollup is EVM compatible or not. So there are a lot of rollup choosing to be EVM compatible because they want to capture the network of developers there already, the L1 developers there already. A lot of developers in this world know about EVM and knows about Solidity and knows about Viper. So they can continue to leverage their skill to develop smart contract for this rollup, right? For those that is not compatible, some of them are very interesting. They don't choose to be EVM compatible because EVM does have its own limitation. So there are certain other chain, they make certain choices. Okay, just to let you know, if you are L2 developers, right, you develop the whole L2, you have the choices, the whole choices in the world, how you want to design you can have a totally different languages, you can totally have a different VM design, and a lot of different account models, all these things. So it's up to you to how do you want to design. So if for those that is not EVM compatible, they have their own other benefits as well. Operators. So this is something you also need to know. Operators is the team or the company that develop the rollup, right? So you got to know whether they are centralized or decentralized. But today, all the rollup are centralized. So I don't know any of them are decentralized today. Maybe I'm wrong, but most of them are centralized, and that is the direction most of them take. They will first go centralized, which is much easier to do, and then they have a decentralization in their roadmap going forward, right? And data availability is something also you need to know. Data availability means that the transaction data that I talked about just now. So for a users to escape from the system, right? Whenever there's something happen to the operators, right? Like zk-sync or the optimism, suddenly the whole team missing, gone. So what can the users do? So users rely on the data that is available previously to reconstruct the whole state. So there are different choices for data availability. They can post the data to Ethereum, which is what I shown just now. Data gets stored in Ethereum. And there are also other choices, like you can choose another off-chain solution, like Celestia, where you can post the data over there, and you can post a different DAC. This is data availability committees can sign a message or a state root saying that your data is actually safely stored in another off-chain solution, and you can put that proof, the commitment into the layer one as a proof that you have already stored the data. And censorship resistant, so you got to make sure the rollup has a mechanism to allow you to submit a transaction anyhow, right? Because the rollup is run by a company or a team, right? The team can censor you anytime. If they don't like you, they can censor you. Let's say optimism, they know that you, I don't know what's the reason. It can be a reason that they censor you. But in today's design or the rollup design, they design a way for users to force a transaction into their chain without needing them to approve or anything. So this is the censorship resistance guarantee that is built into rollup now. If you don't have this, a lot of people will not choose that rollup, right? And programming language, like I said just now, so if you're building a L2, you have all the choices in the world to allow smart contract to be developed, right? You can support Solidity. Zinc is a new language from ZK Sync. Cairo is the one from Stucknet. Sway is the one from Fuel, and you have Rust and others. Yeah, and you also need to know that there are certain rollup that supports special features in their protocol. For example, some of them natively support account abstraction. So like, for example, Stucknet and ZK Sync, they already built in account abstraction into their protocol itself. And there are certain other rollup can do parallel execution. Today, our EVM, our node cannot do parallel execution. That's why the node software does not make full use of the multi-core processor that you have. So some of them, some of the rollup make a change to the VM and enable the parallel execution. Finality. So when you talk about rollout, you also need to know the finality. So finality means you need to know when can you actually withdraw. And there are some soft finalities which says that as and when you submit a transaction to L2, and the L2 will give you a receipt, and you can treat that receipt as a signed receipt as a soft finality. That means if you are building an application that is not so important, let's say just a gaming application, or it's just a coffee shop application, which your transaction may be just like $1, $2. It is not so important. You don't have to wait for the eventual finality to proceed. So you can just take a soft finality to move on with your transaction. Or if you are running a bank app or DeFi app that you absolutely need to be sure the state won't get changed eventually, you probably have to wait a couple of minutes in optimistic rollup, or hours or days in ZK rollup to have the finalization, right? Okay, so talk about some improvement. Okay, this is proto-dank sharding. So just now I talked about L1 changed the roadmap, right? So to not proceed with their ETH 2.0 roadmap. So what are they focusing now? They are focusing now to enable the rollup ecosystem. So this is one of the effort they are putting in. It is called EIP 4844. Proto-dank sharding. Proto-dank sharding is just intermediate milestones for the full dank sharding, right? So what are they adding in here? So the motivation is that today in L2, your fees, most of the L2 fees are the fees for the core data. So just now I talked about we are submitting data into layer 1 and store there, right? So for you to store data in L1, it is very expensive. So those are about 97% of the L2 fees are because of this. So with this change in the L1, they are going to introduce another block transaction, a new transaction type, where the L2 can actually submit more data into L1. And whatever gets stored into this block, it is significantly cheaper than storing the data in core data. So this is how the Ethereum layer 1 is helping the rollup ecosystem, right? So it is introducing something new to make the transaction in L2 much, much cheaper. Okay. So, okay, the blob data will not be there forever. It will be there just like about 1 month. So this is based on the principle that internet never forgets, right? So if you post something into the internet, somehow or other, someone would have a copy of it and can reproduce later, even if you delete the original copies, right? Yeah, so that's it. So that's the end of my presentation. So any questions, anyone? Huh. Uh, yes, yes, yes. I think that for the people on the live stream, so the question is the block transaction, does it require a layer one protocol change, right? So yeah, the answer is yes. There is a protocol change that is needed, and then they added a new transaction type that is tying to the consensus layer. It's not on the execution layer anymore. It's on the consensus layer. So all the I mean, right now they are not doing it, but eventually in the whole full dank sharding scenarios, all the full node would have to validate whether the data is actually available or being available in the data availability layer. So they do this by something called account sample uh, data availability sampling. Is just a technique they use to validate the block data is available there without actually downloading the whole thing, right? So it's just a technique, yeah. Any other questions, anyone? Okay. If not, thank you very much. I think that's it for today's. We can stay back for photo, and also we can stay back for networking. Yeah, there you can also stay back for the food. All right. Thank you.